Hello everyone, welcome back to another video. In this video, we're going to solve a really exciting and practical problem, which is 1 knapsack, right? It's a DP question, and over here we have its objective, which I already have over here, right? So if we read the objective, it says that we are provided with a number n, which represents the count of items. So we will be provided with items. Then it says that you are given n numbers representing the values of n items. So each item will have some value, corresponding value. Then it again says that you have n other numbers which will be representing the weights of all of those items, right? So each item will have its weight and value. So over here, each item will have its corresponding weight and value. Okay. Then it says that you're given a number cap, which is the capacity of the bag that you have. Then you are also provided with a bag. Other than the items, you are also provided with a bag, which would have certain capacity, which is capped. Right? So these are the inputs provided. Okay. What does the question want from us now? It says that you are required to calculate and print the maximum value that can be created in the bag without overflowing its capacity. What does this mean? From the given set of items, you have to pick items such that the sum of the set that you are making after picking the items has its summation of weights smaller than equal to the capacity being provided. Then only you would be able to fit those inside your bag, right? And on top of that, you have to find such set that has maximum value out of all of these. Right? So you would have sets which can fall under the category which satisfy the capacity of the bag. And in all of those sets, you have to pick the set which has maximum value, right? And the value is summation of all the values of the items inside the bag. All right. The note over here says that each item can be taken 0 or 1 number of times, right? And you are not allowed to put the same item again and again. That means simple. You cannot break the items into smaller pieces. You can either take the entire item or you can leave the entire item, right? And also you have limited number of items. You have just one particular unique item associated to each and every value that you have been given. That means there is no repetition that is allowed, right? You can pick an item only single number of times. Okay. If it's not clear, if the question is not clear, let's take an example. Let's suppose you are a pirate, very hardworking pirate, right? Very hardworking pirate, and you are on a conquest of searching treasures all around the world. And when you're roaming around the world, maybe suddenly someday you found a cave, right? You found a cave, right? You went inside the cave, and you had a treasure box over there. The treasure box had precious stones. Treasure box contained precious stones, each having its own worth and own weight. Okay, as a pirate, you had your charming bag. Yeah, good charm, of course. So what you did was you went inside the cave and you started picking the stones. Sadly, your bag could only fit certain amount of weight. So you could pick only a few of the stones that you had available in front of you, right? You have to pick all of the stones such that in your bag you have the maximum value, right? You get the most worth out of it. You can take the most worth out of the treasure that you have just found, right? If you cannot re-enter the cave, right? If you get out of the cave and you cannot re-enter the cave, as a pirate, you would want maximum value in the very first iteration itself, right? You would go inside, you would get the maximum value out of it. You won't say, okay, I would come in the second iteration, because that's not allowed. There's a constraint that only one iteration is allowed. You can go inside only once. So if you're coming out and you know you won't be able to access the treasure once again, ever again, then you would work hard to make sure that you are getting the maximum value in your bag, right? Maximum treasure. This is what 1 knapsack is. You have to pick maximum value out of the given items in your bag such that your bag can hold only a certain amount of capacity. This is what 1 knapsack is, right? I hope it's a bit clear. The question is a bit clear with the example. Now, what we can do is we can take a sample input to discuss it a bit better. Now, let's suppose for input, I have 5 items, right? And 5 of those items are having weights and values. And let's suppose weights are 2, 5, 1, and the values are 15, 14, 10, 45, 50, right? And let's suppose the capacity that is being provided is of 7, right? So my bag can hold a maximum value of 7. Now, to answer this, if I write the output for this question, the output would be 75, right? The output to this question is 75. This is by using these two items of 3 and 4 weight. So the weight is equal to 7, and if we look at the values, which is 45 and 30, if we add them both, we get 35. Of course, there are other sets which fall under the category that they sustain the capacity of the bag, but this is the set which has the maximum value out of all of them, right? If we take the first two elements, which are having weight 5 and 2, if we add them both up, we get 7, right? So this also satisfies. But if we look at the values that they provide, it's 14 and 15. That is a total of 29. So the value that they generate is just 29, right? But in this case, it's 75, not 55, 75, right? Hence, this is the set that has maximum value. Okay. Now, I hope the question is clear, and I would want you to try this question on your own first. If you get stuck somewhere, take the help of either the tutorial or the solution video, and I'll see you, right? Now, let's discuss the solution to this question. Now, the solution would be of the type of DP, of course. Now, if we recall, in past, we have solved questions like target subsets. We have solved many other questions like count encodings and stuff, in which we use the principle of inclusion and exclusion, right? Now, if we try to relate that concept with the question that we have in hand, which is One Knapsack, what we can do is at every step, we can either decide if we want to include the particular item or if we want to exclude the particular item, right? That is, if I include the item, what is the value that I get rather than if I exclude the item, right? So I can basically maximize the steps in which I include and exclude an item. I can see what is the value that I'm getting after including an item and what is the value that I'm getting after excluding an item, 1 and 2. And whatever is the maximum of these two is something that I would be doing. I would either include or exclude an item, right? So as this is a DP solution, the 3 steps that we do, of course, the very first step, which is assigning storage, right? And meaning. Second is, of course, deriving a direction. Third is traversing and solving, right? So to do this question, I've already created a 2D DP over here. This is a 2D DP integer array of size n plus 1 cross capacity plus 1, right? So for the question, for the test case that we just discussed, where we had 5 different elements and capacity of 7, this is the 2D DP array that we have created, right? Let's look at the meaning of each and every position, right? So what would be the meaning of this point, let's suppose, right? If I draw this with red, right, this point. So this is DP of 2, 6. This would mean by using first 2 items, what is the maximum value that I can generate when the capacity is 6? Right? By using these 2 items, what is the maximum capacity that I can generate at 6? This is what it means, right? If I take another example, let's suppose this, right? This is DP of 5, 7. What does this mean? This means by using 5 elements, 5 of the items that we have, that means all of these items, right? All of these items, and with the capacity of 7, what is the maximum value that I can generate? So with 5 items and 7 as the capacity, isn't this our question itself? Our question says that for all of these items and the capacity of 7, what is the maximum value that I can generate, right? So this particular point will be my answer, right? So this is nothing but my answer over here, DP of 5, 7, which is DP of n cap, right? This would be my answer. Now, if you observe, we have 0 over here, right? We have 1 indexed. All of these items are now 1 indexed. So very first item is not starting from 0, it's starting from 1. What does the first column signify? First column signifies that for 0 items, what is the maximum value that I can generate? Can I generate any value using 0 items? I cannot, right? So that means this would always remain 0, because if we are not using any item, then the value is automatically 0. Now, if we observe the very first column says that what can be the maximum value when the capacity is 0, right? If the capacity is 0, can I fill anything in the bag? If my bag cannot withstand anything, that means its capacity is 0. Can I fill anything in the bag? No, I cannot. That means that the first column itself would also be filled with zeros throughout, right? Now that we know 2 things out of 3, what? The very first thing, assigning storage and meaning. Now we know the storage and the meaning, the direction in which we have to solve. We know that where we would get our answer. We would get our answer in the very last row and column, the very last cell that exists, right? So we would move in this direction, forward and downwards, right? So if you come over here, the direction is forward and downwards, right? Now the last step, which is traversing and solving. So let's see how we can do that. Again, keep in mind inclusion and exclusion principle that we talked about, right? We would get 2 different values after including or excluding an element, and we would see which value is greater, and according to that we would place our element, right? So if I erase the size part, and if we now run this, now what does dp of 1 and 1 mean? This means that for the very first element, which has a weight of 2, what is the maximum value that I can generate when my capacity is 1? Can I fill my first element when the bag's capacity is 1? Given that the weight of the first item is 2. No, right? I can only and only fit an item inside the bag if the weight of the item is greater than equal to capacity of the bag, which is current capacity, which is J. Let's suppose these columns are denoted with J, right? If my weight is smaller than equal to J, then only I can place it, right? Other than that, I can only exclude it. So at this point, I can either exclude this particular item or include this particular item. But as the capacity is 1, I have no other option rather than excluding it, right? So if I exclude the very first item, what is the cost that I have? For that, I have to look at the previous row, right? The cell just in the previous row, right? This would mean, what would this mean? The maximum value that I was able to generate when the capacity was the same, but I was not using my item, right? Till the items before me, right? Which is 0. So this becomes 0 itself. Now the capacity of the bag is 2 and the weight of my item is also 2. That means I can both include and exclude my item. So if I include my item, right? If I include my item, then the current capacity, which is 2, I would subtract my weight from it, right? As my weight is 2, 2 minus 2 would give me 0. What I would do is, I would check for capacity equivalent to 0, what was the maximum value that was generated when I wasn't included, right? So for that, I would go 2 steps back, which is my weight, and I would check the previous row. Previous row would contain the data of maximum values that was generated when I wasn't included in the answer, right? As I'm including myself already, I have to check when I was not included in the answer, what was the maximum value. And for that, I would check for previous row, right? And over here, as we have 0, that means if I include myself, I would get 15 as value, plus I won't get anything because the maximum value before me was 0. This is when I include myself. What happens if I exclude myself? When I exclude myself, I just check for previous row, which is 0. So if I exclude myself, I'm not having any kind of value, right? Because before me, there was no item, or there was no item present. I'm the very first item, right? So if I see my inclusion is greater than my exclusion, right? So I have to include myself at this point, right? So what I would do is I would include myself, and if I include myself, I would get 15 over here. Again, when the current weight is 3, if I exclude myself, I would get 0. If I include myself, I would get 15 plus 0, which is 15. 15 over here. Again, if I include myself, I would get 0 and 15, which is 0 plus 15 is 15. And if I exclude myself, I would get 0, which is 15. Right? Throughout this row, as I cannot include anything other than me, right? Because I am the very first item, everything would be 15. Hope it's clear. Because I'm the very first item, I know that the row previous than me, before than me, would be 0. So after the capacity which can sustain me, my answer would be equivalent to my own value, right? Again. Now, we have processed the very first element. This is done. Now we would process this element, which is having a weight of 5 and value of 14. Right? Now, as it has a weight of 5, it can only be included after this point. Up till this point, it has to be excluded always. Right? That means at this position, when the capacity is 1, if excluded, it would get maximum value of 0. If excluded, it would get a maximum value of 15. Right? So if I had a bag which had a capacity of 2, I filled it with 2 with 15, and then I excluded 5 and 14. Right? This would give me a total value of 15. Right? So I exclude myself and I get 15. Again, I get 15. Again, I get 15. Now at this point, what I can do is I can either exclude myself or include myself. So let's see. If I include myself, I would of course get my own value. Plus, I would get the value that was maximum mine when the capacity is 5 minus 5, which is 0. Right? If I'm including myself, that means I am using the capacity of 5. And if my bag was of capacity of 5, I'm left with 0 capacity. So the left out capacity is 0. Right? And the maximum that was generated without me at that capacity was 0. Right? So I can either have 14 over here, because 14 plus 0 is 14, or if we check for exclusion now. If I exclude myself, I can generate a maximum of 15. Right? If I don't include myself, then for the capacity of 5, till my previous item, the maximum value that was being generated was 15. That means 14 versus 15. It's better if I exclude myself. What I would do is I would exclude myself. I hope it was clear. It was really important. If you didn't quite get it, wait till this point. After this, we would be able to derive all the possible situations, right? Now, if I move to 6, that means my current capacity is 6. Again, I can either include myself or exclude myself, right? If I exclude myself, let's suppose if I exclude myself, that means I'm not including myself. What was the maximum value that was generated when the capacity was the same, but I was not included, which is the previous row, which is 50. Right? So if I exclude myself, I would get 50. What if I include myself? If I include myself, I would surely get 14. And with the remaining capacity, that is 6 minus 5, remaining capacity of 1, what was the maximum value that was generated? The maximum value that was generated was 0 again. Right? So 14 plus 0 gives me 14. 15 versus 14, again, it's better if I exclude myself, right? So I hope you see what we are doing is we are checking for inclusion and exclusion, and where we get the maximum value, I am doing that for the particular item, right? Now, if we move to capacity of 7, if I exclude myself again, the maximum value that I get from previous row, of course, is 15, right? And if I include myself, I'm getting 14 plus what I would get is dp, I'm writing the formula over here now, dp of my previous row, right? So the previous row is, let's suppose, r minus 1. And what was the column? The column would be the current column, which is the current capacity minus my own weight. So the current capacity, which is J, minus my own weight, which is WT, right? So if we see J minus WT, which is 7 minus 5, which is 2, and the previous row, it's 15. So 14 plus 15 over here, right? Which is 29. That means at 7, I can include myself, and after inclusion 2, I can make a maximum value of 15, right? So if I include myself, I would get 29 value. If I exclude myself, I can make a maximum of 15 value, right? Of course, inclusion wins in this case. So that means I would include myself finally, which is 29 value, right? So we have processed these two items, right? Let's quickly run through the rest of the items. Okay, let's not erase that. Yeah, okay. Okay, so this is also processed. Now 1 for 10, right? 0 won't do anything. For 1 for 10, can I fill when capacity is 1? Of course I can, because the weight is equivalent to the capacity. That means I can include myself. If I include myself, 10 plus 0, which is 10, right? Exclusion would have given me 0, inclusion gives me 10. Of course 10 wins. Now in this case, I can include myself or exclude myself, right? If I include myself, I would get 10 plus 0, which is 10. Exclude myself, I would get 15. So 15 wins. Now in this case, if I exclude myself, I would get 15. But if I include myself, I would get 10 plus 15, which is 25, right? Hence I get 25 over here. Again, at this place, exclusion would give me 15. Inclusion would give me 10 plus 15, which is 25. At this point too, 25, 25. Now at this point, exclusion would give me 29, right? Exclusion would give me 29. And inclusion would give me 25. Exclusion wins. It's better if I don't include myself and let the rest of the two elements stay in the bag, right? That means 29 over here, right? Now this is also processed. For 3 of 45, again, I won't be doing anything up till here because the capacity is smaller than the weight itself. So I would only exclude myself. That means 10 and 15 over here, right? Now from 3, I can either include myself or exclude myself. So if we see over here, if I exclude myself, what do I get? I get 25 as value, right? If I exclude myself, I get 25. And if I include myself, I would get what? My own value, which is 45. And I would check for this position, which is 0. So 45 plus 0 is 0. But if I include myself, I would still get 45. That means I would be including myself and getting 45 as value, right? Now at this point, if we see, if I exclude myself, myself at this point, I would get 25 as value, right? At this point. And if I include myself, I would get 45 plus 10, which is 55, right? Because this minus 3 gets me to this point, right? Which is 10. So 45 plus 10, which is 55. So of course, inclusion wins in this case too. Hence, we just erase this and this, and we have 55 over here, right? Now again over here, we have 25 in exclusion. And in inclusion, what do we have? We have our own value, 45. And if you go back, we have 15 from here, right? So 45 plus 15, which is 60. Right? So 25 versus 60, 60 wins. That means I should include myself at this point, right? So again, at this point, it's 25 versus over here. If we come, this is 25, right? So if I exclude myself, we have 25. And if I include myself at this point, I will go back 3 positions. I would check it's 25. So if I include myself, I would get 45 plus 25, which is 70. Of course, 70 wins, right? So we remove this. Yeah. So we have 70 over here, right? Again, at this point too, what we would have is in exclusion, we would have 29. And in inclusion, if we see again, which it's the 25, 45 plus 25 gives us 70. 70 wins, comes over here, right? And therefore, we have processed this item. Now we would be working for the very last item, right? And the very last item could only be included after this point, right? Because before this, the capacity is smaller than the weight itself. That means it can only be excluded in these three parts. Now, when the capacity is 4, I can either include myself or exclude myself again. So if I exclude myself at this point, I would get 55 as value. And if I include myself, I would get 30 as value, right? So I exclude myself, right? I'm maximizing, right? So over here in 5th position, if I exclude myself, I would get 60. If I include myself, I would get 30 plus 10. So we have 30 plus 10, which is 40, right? So 40 versus 60, 60 wins. That means I should exclude myself, right? Let rest of the items fill the bag. Okay. For value 6, what should we do now? For value 6, if we do 6 minus 4, we go to 6 minus 4, this point, right? Okay, so 6 minus 4 lands us at this point, which is 30 plus 15. 30 plus 15 gives us 45, right? So if I include myself, I would get 45. But if I exclude myself, I'm getting 70. That means I should exclude myself and let the rest of the items fill the bag. Now for the very last position, let's see, right? So very last position in which if I include myself, then I would get my own value, which is 30, and then I would go 4 places back and I would check the maximum value, which is 45, right? So 30 plus 45 will give me 75. If I include myself, I'm getting 75. If I exclude myself, I'm getting 70. That means over here, the maximum value that I can generate is 75 after including myself, right? And this is where my answer was, and this is what my answer is. So 75 is my answer. I hope you understood how I traversed through it, and how we got the answer, and how inclusion and exclusion principle is something that we utilize for maximizing our result. Let's try to code this now, right? So if we take this to full screen, what I want to take in input is 2 arrays, right? So first of all is the number of items, then is the weights array, and of course, okay, let's see. Okay, so the very first one is the values array. Yeah, if I write over here for int I equals 0, I goes to n, I plus plus, right? So value of I take as input, and then I have my weights array, which is new int n for int I equals 0, I goes to n, I plus plus, and weights of is equal to new int of n. Okay, sorry, this is c dot next int, right? Now after the values and the weights, what I have is the capacity. So I would take cap as input, c dot next, right? Okay, now that you have taken the input, what I will do from here is solution. The very first step is to assign storage. What was my storage? My storage was a 2D DP integer array of size n plus 1 and capacity plus 1. So integer dp is equal to new int n plus 1 cross cap plus 1, right? Now, what was my base case? My base case was that my 0th row and 0th column will be 0. Now, as the default value in Java for all the integer spaces in the array are 0, we don't need to initialize that. So we can move forward and we can traverse. How do we traverse? We traverse from we traverse through the columns from 1 till the capacity of the column for each and every element. So we process each and every element one after the other, right? So very first loop would be for all the elements, which is going from 0 till 1 till n, actually, because the 0th row is our base case, right? And over here, what we would have, so over here, what we would have is value, which would be I minus 1, as it's 1 in text, as we saw, and we would have weight, which will be weight of I minus 1, right? For each of the items, we are traversing through the capacity. So I is already used, so j goes from 1 till j is capacity j plus plus. Now, what we have to do is we have to check if my weight, if my j, which is the current capacity, is greater than equal to my weight. If my current capacity is greater than equal to my weight, then only I can include myself, right? Then only I can include myself. That means dp of ij would be math.match I minus 1 j dp of I minus 1 j minus of weight, right, plus my value. So if you see over here, this part is my exclusion and this part is my inclusion, right? This is the formula that we wrote for inclusion. If this is not the case, I can only exclude myself. That means dp of ij would always be dp of I minus 1 j, right? After running through these loops, after traversing and solving, I would have my answer at dp of n in capacity. So system.out.println, we have n and capacity over here, right? Let's run this and see if it works. So it does work for the test case. Let's submit and run for all the test cases that we have. And it works. We are getting 10 out of 10. So I hope you understood what we did over here, right? So go back and look at how we were including and excluding. So this is my inclusion. Sorry, this is my exclusion. What we are doing over here is just checking for the previous row for the same capacity. So this is my exclusion. And this over here is my inclusion, right? And we are writing this if conditions to make sure that we don't get index out of bound. And if we are not able to include, then of course this is for exclusion, right? What we are doing is we are maximizing both of them. And we are keeping that value in the dp of ij. And at last, we would get our answer over here. So I hope you understood. You can go back and watch the dry run again and keep in mind the code that we have written, right? So talking about the complexity of this, the time complexity is O of n cross cap, right, to generalize O(n) square. And what is the space complexity? Space complexity, again, using a 2D integer dp of size n plus 1 cap plus 1. So it's also, of course, n cross cap size. almost. So O(n) square to generalize, right? Okay. So I hope you understood. I hope you understood how we used inclusion exclusion principle to maximize our solution. If you like the video, please share it with your friends, and I will see you in the next video. Bye bye.